It's usually just 2 days behind. All right, class. All right, good day, good day. All right, so a couple things. I am going to actually address this first, especially for those people that are not here that are actually watching the videos. Quiz retakes for quiz 2. The last day to do it is going to be Wednesday next week. And if you need to redo quiz 3, you can start doing that this weekend at Saturday school. There is Saturday school this weekend, so if you have to do the retakes, you need to do the retakes. Saturday school is probably your best bet. Okay? So that's going to be the best way to do it. Because after school is not working out very well for me because I have coaching every day now. So I want to make sure you guys do have the opportunity. You can go to other teachers to do test recoveries. Okay? You can go to 701 or you can go to Mr. Hagan to do test recoveries. Okay, so that's for everyone out in YouTube land. Yes. Okay, I'll update it in class. Okay. All right, so let's go through this. So today, hashtag 41, today's date. 19? Yeah. And, okay, so every single time we keep doing this, I am going to rewrite it. I'm going to write my rules for my logs. So I have b to the y equals x log base b of x equals y. Now, what would be the new way of doing this with e now? Yeah, so if I were to rewrite that, that would be e to the y equals x, right? Yes? Okay, so because e is just, or ln is just log base e. So if I were to log this, it becomes ln of x equals y. Remember, because all I'm doing is changing this to be log base e, but log base e is ln. Okay, that's all I'm doing right there. I'm changing that. Okay, so these two things are going to be super helpful. So top of your paper, top of your homework when we're doing this, have this on there and it's going to help you later on. Okay, here's a graph that represents exponential function base e defined as this. So this is my function here. Okay? So now for this, if this is going to be ln 100, that would mean where is this? Because if I were to rewrite it in exponential, wouldn't it be where is e to the x equal to 100? Yeah. So all I have to do is I go to my graph. So where is it going to be equal to 100? 4.5? There we go. So right about there, right? So we're going to say that it's going to be about 4.5. That's super easy, right? I hope so. Okay, I'm hoping everyone's paying attention, don't have earbuds in, and are not playing with their phone, and every time I look up, just sliding it over, pretending like it's your calculator. Yeah, I see you back there. So, hey. Thank you. All right, so how can you use a calculator to check your estimate? So let's go ahead and put it in the calculator, and I'm just going to write ln of 100. So I'm going to clear mine so you guys actually see starting from the beginning. So I have ln. To get to my ln, I have to hit control first. So it's going to be control e to the x. So there's my ln. Put in my 100. And should be about 4.6. All right, so I'm actually writing it right below. Because right here, we approximated it for that. Okay, I checked it right here. It's pretty close, isn't it? Okay, that should be pretty easy. Looking at stuff in the graph and then pulling that out. Okay, so this next part is exponential growth and exponential decay. So I'm going to put up some formulas that you guys might remember because we've been using it. it's P to the RT, P times RT, and the other one is P E to the RT. Both of them are basically the same. They're really close in this function right here, and this one right here is going to be, we did the differences on the graphs, one when I was teaching you guys how to vars on the calculator. So they're both the same thing. But do you guys remember, what does P represent? Initial value. Okay, good. So my initial value, it says right here, the expression here, balance thousands of an account T years after it's open. What is the account balance when the account is open? What's my initial? But these are in 1,000, so it's going to be 1,000, right? So I'm going to write 1,000. Always remember, okay, if this is not just 1, this is representing 1,000. So I know everyone's paying attention, not playing on their phones 40 of the time. That's all right. Now, after 1 year. So after 1 year, I'm going to plug that into my function. Okay? So that means that my t value here is going to be 1. So I would like you people right now to please put it in your calculator. Please put the equation in your calculator, and what am I evaluating for? 1, right? I'm plugging in 1 for my value. Sure. So I'll pull up mine.
You said put in 1 in for the t value?
Yep, 1 for the t, because it's asking for 1 year, right? And all my t's are in years. So 1 times e to the 0.06 times 1. Okay.
Is it okay if I put it in 1,000?
Yes, I'm going to get to that here in a second. Because when we're talking about this, we're actually talking about real money here, right? Okay, we're talking about money. And so every $1 or every 1 represents 1,000, right? So to figure out in real money, what would I do to figure out the dollar amount? Times it by 1,000. Very good. So let's do that. Times it by 1,000. So my dollar value is actually 1,061.84. So now I need you guys to think on this real quick before you shout it out. How much money did we make? Why is it $61? My initial value is 1,000, right? I'm not making 1,061. I'm making only 61 because my initial value, that's how much I start off with, is 1,000, right? The 61 is on top. That's actually the profit. Okay, that's the money that you make off of it, is the 61.84. Okay? So the next question says after 2 years. I would like for you guys to tell me what the account balance is after 2 years. Account balance after 2 years. All right, so what does that mean? What am I replacing now, Angel? What am I replacing now?
For which question? Oh, for C?
Yeah, what are we doing?
We're replacing T with 2, which is 1, and change that to 2.
Change it to 2, very good, and I get?
That, but you want to get your dollar amount, so then you times it by 1,000.
Very good, times it by 1,000.
Right.
There we go. 1,127.50. because it's dollar amount, so that 0.5 represents 50 cents, right? Okay, so now this next piece, there's not really enough room on this in the paper. So you guys, I would like for you guys to actually use the line paper. So, says Diego says the expression Ln5 represents the time in years when the account will have $5,000. Do we agree? Okay. Ln5. Let's figure out what is Ln5 first. So, let's figure it out. Not take a nap. We are figuring out what Ln5 is going to be. That means someone's got to plug it in the calculator, not look at me awkwardly.
1.60944.
1.06944. Very good. All right. 1 point what? 609?
60944.
Like that? Okay, thank you. I'm sorry, Angel actually messed me up on that one. Okay. All right, so now let's see. So if I have my function, which is going to be 1 times e to the 0.06 t, like that. Now, I want this account, this function right here, to equal 5,000, right? So what am I going to set this right here equal to? Not 5,000. Why 5? Yep. Each one represents 1,000, right? So we're going to set this equal to 5. So let's go ahead and do some math. Okay, so we're going to try and get this by itself, but 1 times e is just e, right? So my base is here, right? My y value is here. My x is here. So let's log this. Or in this case, ln, right? So I'm going to write ln of what? Ln of 5. Remember, we're taking this, which is over here, right? So I'm lning, right? So it's ln of 5 is going to be equal to, so it's going to be 0.06 t, right? Now, we're trying to solve for t, aren't we? So what would I do to solve for t? Very good. Divide by 0.06. Now we have a value for t. So we could figure out what this is going to be. So from my word problem, the person said it should only be about a year and a half, basically, to get $5,000. But we just did all the math here. So let's see what this is going to give me now. So you guys are going to calculate this. I know you guys are calculating it, right? So we have, let me see. Control, divide, ln of 5. So 26.824. Now, what does that represent? You guys, help me out. What does that represent? What is t in this problem? Years, right? Scott, you okay over there? You okay? You okay? Scott, you all right? Okay. All right, so this is going to be in years. So, do you think these are the same? They're not the same, are they? So this says, according to my problem, look it back into my problem. What is this actually going to mean? It'll take 26 years for what? For my account to be 5,000. Yes. So that is incorrect to what they said. So it's about 26 years or 27 years, basically, for my account to finally hit 5,000. So I'm going to write down my reasoning here.
He's like, can I just put 26? I went to 27.
Yeah. Okay. It's fine. But if you notice, I just rounded it. So we did the work over here, but on your paper, you guys are actually doing it on the line paper, right? I have a different piece of paper because I have 4 classes, and I can't do the same on the same line paper. Because I only could use my line paper once. Okay? So, there we go. So it's about 26 years for the account to be $5,000. Alright, let's see. Suppose you open this account at the beginning of this year. Assume that you deposit no additional money and withdraw nothing from the account. Will the account reach $1 million and make you a millionaire by the time you reach retirement? Angel, okay, what do you plan on doing for a living? Marketing. You're going to be marketing, right? So how many years do you think that you're going to be working in this marketing program? So you're going to get a job with a great, you're going to stick with the job for however many years. How many years are you going to work with it?
Is this based on the question or based on me?
Based on you.
Forever.
Forever. Okay, so you're never going to retire. Hopefully? Okay, so that doesn't help me out. So let me see. Luis, he's going military. Okay, he's going military. Yes, he's going military. He's going, do you know what the retirement is for the military? How many years till you could retire? 20. You could retire and get a paycheck for the rest of your life after 20 years.
Is that what you did?
No. Okay? So, now listen. The reason why I'm actually referring to this is because according to this problem, some people retire after 20 years working at a job or 30 years. Teachers actually normally have a 30-year retirement. So, okay, me being a teacher, yeah, let's say I work for 30 years. Using this same problem, hey, George, please. Using this same problem, will I be a millionaire after 30 years? Why? Huh? Okay, I agree, but give me a better reason. Now,
Only a grant for a year.
do what?
Oh, wait. Oh.
Thank you. Thank you. Right there. Loud and clear. Say it again. It took 27 years to get to 5,000, didn't it? So if I have a 30-year retirement, do you think I'm going to actually hit $1 million in 3 more years? No. No. That one's not going to work out. Okay? Definitely no. Huh? Go back to the military. I will tell you I'm making considerably more than what I did in the military.
Can you go back if you wanted to?
Yes. Certain people can, others cannot.
You invest in stocks?
Okay. Now, listen. This is where I'm going to abbreviate this set of notes right here. So this is going to be the last type problem we're going to do. It says that population of cicadas is modeled by a function defined by f of w equals 250 times e to the 0.5 w. Okay? Where w is the number of weeks since the population first measured. Explain why solving the equation gives the number of weeks. So, let's take a look at what we're doing here. So, my population is going to be how much? 500. So, I'm going to set up my problem. 500. Yeah, go ahead. Equals 250 e to the 0.5 w. This is probably the main topic of all these questions we're doing today. So what am I going to do? I'm going to try and solve for w. What do you do? Divide by 250. Very good. Divide by 250. So when I divide that, 500 divided by 250. So I get 2 is equal to e to the 0.5 w. Right, Jocelyn? Yeah, So what would I do here to try and get the w by itself? No, not divide by 0.5. ln. I got to ln it here, right? So it's going to be the ln of equals, not e, 0.5 w, right? Now, to get the w by itself, I need to divide both sides by So now that's going to give me the w. So I'm going to look at it. Let's go ahead and look at it in my thing here. So we had control divide ln of 2 over 0.5. Okay, so it's going to be 1.39. Now, in the context of this problem, what does that represent? Weeks, right? Now, go back to the problem. What's it actually say, though? That's going to be weeks for what? For my population to double. That's going to be how we're doing this. So, everything that we're doing going along goes back to this. Solving for ln, solving for my variable, what you learned how to do yesterday. Okay, so I'm going to leave off right there. And that's basically it. We have the summary of the same stuff that we've done. So I'm going to give you guys the rest of the time to try and work on your assignment. Like, share, and subscribe.